Today we are on page 10 of our Chapter 3 Notes Packet, Section 3.8, Solving Radical Equations. Following these steps, to solve equations that include radicals, first you isolate the radical. It's very, very important that the radical be isolated before you start. Square both sides, or cube if the radical is a cube root. Solve, and then you must check back in the original equation. Beware, squaring both sides sometimes produces an extraneous solution. For practice, A, we have the square root of x is equal to 5. The radical is isolated, so we square both sides. Square root of x squared is x. 5 squared is 25. So x equals 25. Check. Go back to the original. Does the square root of 25 equal 5? Yes. B, the square root of 5x equals 10. The radical is by itself. It is isolated, so we square both sides. Square root of 5x squared. Squaring a square root just removes the square root symbol, remember, so this is just going to be 5x equals 10 squared is 100. Divide by 5. X equals 20. Check. Does the square root of 5 times 20 equal 10? Yes. 5 times 20 is 100. The square root of 100 is 10. 10 equals 10. C. The square root of 4x plus 2 equals 8. Solving this, first isolate the square root of 4x, so we subtract 2 from both sides. The square root of 4x equals 6. Radicals isolated, so square both sides. 4x is equal to 36. Divide by 4. X equals 9. Check. Does the square root of 4 times 9 plus 2 equal 8? 4 times 9 is 36. The square root of 36 is 6. 6 plus 2 is 8. 8 equals 8. So that checks. D. 7 plus the square root of 3x equals 1. Isolate the radical, so subtract 7 from both sides. The square root of 3x equals negative 6. Square both sides. 3x equals 36. Divide by 3. X equals 12. Check. Is 7 plus 3 times the square root of, is 7 plus the square root of 3 times 12 equal to 1? Well, 3 times 12 is 36. The square root of 36 is 6. Is 7 plus 6 equal to 1? No, 7 plus 6 is 13. 13 does not equal 1. So 12 is extraneous, so there's no solution. Or if we're writing solution set notation, it would be the empty set. E, we have cube root of 5x plus 75 equals 5. Okay, the radical is isolated, so we'll raise both sides to the third power. 5x plus 75 equals 5 raised to the third is 125. Subtract 75 from both sides. 5x is equal to 50. And divide by 5. X equals 10. Check. The cube root of 5 times 10 plus 75, does that equal 5? 5 times 10 is 50, plus 75 is 125. The cube root of 125 is 5. 5 equals 5. That checks. So always isolate the radical. Next, if there is a coefficient with the radical, square or cube the coefficient also. For example, x equals 2 times the square root of x. Right? So there's a coefficient 2 with our radical. So we will square both sides, squaring the 2 as well. So x squared equals 2 squared is 4. The square root of x squared is x. So x squared equals 4x. This is quadratic, so put it in standard form. Subtract 4x from both sides. X squared minus 4x equals 0. Factor GCF x times x minus 4. Set each factor equal to 0. Usually skip that part, go right to the two values, x equals 0 and x equals 4. We must check. Back to the original. Putting in 0. Is 0 equal to 2 times the square root of 0? Yeah, square root of 0 is 0. 2 times 0 is 0. That checks. Plugging in 4. Is 4 equal to 2 times the square root of 4? Square root of 4 is 2. 2 times 2 is 4. So yes, 4 equals 4. That checks. So both solutions remain. X equals 0 and x equals 4. G, 3x equals 2 times the square root of 3x minus 1. We have this coefficient with our radical, so we will square both sides. 3x squared, that's 3x times 3x, that's 9x squared, equals 2 squared is 4. And the square root of 3x minus 1 squared is 3x minus 1. Make sure you put that in parentheses because we'll have to distribute the 4. So 9x squared equals 12x minus 4. Again, it's quadratic, so put it in standard form. Subtract 12x. Add 4. Now we need to factor. We need to multiply. 9 times 4 is 36. The factors of 36 that add to negative 12 are negative 6 and negative 6. So we end up with, you would do 9x minus 6, go up here, 9x minus 6 times 9x minus 6, divided by 9. You break down 9 into 3 times 3. 3 divides into one binomial, 3 into the other. So we end up with 3x minus 2 times 3x minus 2 equals 0. Setting each equal to 0. You only need to solve one. They're the same root. Add 2 to both sides and divide by 3, and x equals 2/3. We need to check. 3 times 2/3. Does that equal 2 times the square root of 3 times 2/3 minus 1? 3 times 2/3, that's 3 over 1 times 2 over 3. The 3's would divide out, that would be 2. And on the other side of the equation, 3 times 2/3, that was 2. Subtract 1 is 1. So 2 times the square root of 1, which is 1, is 2. So 2 does equal 2. That checks. So our solution of 2/3 remains a solution. So if there's a coefficient along with the radical, you square, cube the coefficient as well. Now, if there's a binomial on one side of the equals, you must FOIL. This is often forgotten. So in other words, we have this binomial x plus 2 is equal to the square root of 3x plus 16. Okay, the radical is isolated, so we square both sides. And we have to FOIL, right? X plus 2 squared means x plus 2 times x plus 2. You don't distribute over a plus or minus. Okay, so foiling, this is going to be x squared. Outside is 2x, inside is 2x, and the last is 4, equals 3x plus 16. Combining x squared plus 4x plus 4 equals 3x plus 16. Subtract 3x and subtract 16. X squared plus x, and 4 subtract 16 would be negative 12, equals 0. So we have our equation in standard form. It's the easier factoring. The coefficient is 1 here, so the factors of negative 12 that add to positive 1 are positive 4 and negative 3. So x plus 4 times x minus 3 equals 0. Setting each equal to 0, skipping that step, going to x equals negative 4 and x equals 3. Again, we need to check. We must check. Back to the original. Is negative 4 plus 2 equal to the square root of 3 times negative 4 plus 16? Well, negative 4 plus 2 is negative 2. 3 times negative 4 is negative 12, plus 16 is 4, and the square root of 4 is 2. 2 does not equal negative 2, so negative 4 is rejected. That's extraneous. Check 3. Is 3 plus 2 equal to the square root of 3 times 3 plus 16? 3 plus 2 is 5. 3 times 3 is 9, plus 16 is 25. The square root of 25 is 5. So yes, 5 equals 5. That checks. Our answer, x equals 3. For I, again, you might want to pause the video and try it on your own. Isolate this radical, so subtract 4. Just to save room, I'm not going to show that, so we would end up with x minus 4 is equal to the square root of 2x minus 8. Now the radical is isolated, so square both sides. You're foiling this. This is x minus 4 times x minus 4. And square root of 2x minus 8 squared is simply 2x minus 8. And this is going to result in the trinomial x squared. Outside negative 4x, inside negative 4x combined to be negative 8x. And the last negative 4 times negative 4 is positive 16. Put it in standard form, subtract 2x and add 8. Subtracting 2x from negative 8x is negative 10x. Adding 8 to 16 is 24. Factors of positive 24 that add to negative 10, negative 6 and negative 4. So x minus 6 times x minus 4 equals 0. Set each equal to 0. And you get x equals 6 and x equals 4. Again, we must check back to the original equation. Is 6 equal to 4 plus the square root of 2 times 6 minus 8. 2 times 6 is 12, minus 8 is 4, the square root of 4 is 2, 4 plus 2 is 6. So yes, 6 equals 6. That checks. So 6 is a solution. Checking 4. Is 4 equal to 4 plus the square root of 2 times 4 minus 8? 2 times 4 is 8. Subtract 8 is 0. The square root of 0 is 0. So yes, 4 equals 4. On to page 11. If there are two radical parts in an equation, arrange one on each side of the equal sign and square both sides. Okay, so here in J we have two radicals. They're already on either side of the equation, so we simply square both sides. So the square root of 5x minus 3 squared is simply 5x minus 3, and the square root of x plus 13 squared is x plus 13. Well, this is nice. We don't have a quadratic, it's just a linear, so I'll subtract x from both sides. 4x minus 3 equals 13. Add 3 to both sides. 4x equals 16, and divide by 4. X equals 4. Always check back into the original. Is the square root of 5 times 4 minus 3 equal to the square root of 4 plus 13? Well, 5 times 4 is 20, minus 3 is 17. Square root of 17. 4 plus 13 is 17. Yes, square root of 17 equals the square root of 17. So 4 is a solution. And K, we've got two radicals, so we'll place one on the other side. I would add the square root of t plus 25 to both sides. You don't have to show this step. So we'll have 2 square root of t plus 7 equals the square root of t plus 25. Now square both sides. Remember, that's 2 squared is 4, and the square root of t plus 7 squared is going to be t plus 7. Make sure you put that in parentheses because we'll have to distribute the 4. And the square root of t plus 25 squared is t plus 25. Distribute the 4. That's 4t plus 28 equals t plus 25. Again, it's linear. There's no quadratic term. I'm going to subtract t on both sides. And the same step, subtract 28. So we have 3t is equal to negative 3. Divide by 3, and t equals negative 1. Go back and check in the original equation. Is 2 times the square root of negative 1 plus 7 minus the square root of negative 1 plus 25 equal to 0. Well, negative 1 plus 7 is 6. So it's 2 square root of 6. Subtract that's 24. The square root of 24 equal to 0. Well, let's see. If we simplify the square root of 24, that's 4 times 6, so that would be 2 square root of 6. Is 2 square root of 6 minus 2 square root of 6 equal to 0? Yes, 0 equals 0. So t equals negative 1 is a solution. Now, just try the next 4 problems on your own. All right, pause the video, try the next 4. Okay, we have the cube root of 9x equals 3. The radical's isolated, so we'll raise both sides to the 3rd power. We get 9x is equal to 27. Divide by 9. X equals 3. Check. Is the cube root of 9 times 3 equal to 3? 9 times 3 is 27. The cube root of 27 is 3. So yes, 3 equals 3. Number 2, the radical is isolated. It has a coefficient with it. That's okay. We will square both sides. 2 squared is 4. Square root of x squared is x. So 4x is equal to 6x squared is 36x squared. It's quadratic, so put it in standard form. I'll subtract 4x from both sides. I'm not showing that. I get 0 equals 36x squared minus 4x. There's a GCF. I'll factor that out. 4x. So 4x times 9x minus 1. Set each equal to 0. 4x equals 0. 9x minus 1 equals 0. So dividing by 4, x equals 0. Adding 1 and dividing by 9, x equals 1/9. All right, we'll have to check these two values. Is 2 times the square root of 0 equal to 6 times 0? Yeah, 2 times 0 is, well, 0. 0 equals 0. So 0 is a solution. Is 2 times the square root of 1/9 equal to 6 times 1/9? The square root of 1/9, 1 is a perfect square, so is 9. Square root of 1 is 1, square root of 9 is 3. So this is 2 times 1/3, which is simply 2/3. Is that equal to 6 times 1/9? Well, 6 times 1/9, we could reduce if we wanted. 9 goes in, or sorry, 3 goes into 6 twice, and 3 into 9 3 times. Or you can simply say 6/9 and reduces to 2/3. So yes, 1/9 is also a solution. Number 3, isolate the radical, subtract 2 from both sides. Square root of 3x minus 16 equals 8. Now square both sides. 3x minus 16 equals 64. Add 16, it's linear. It's 80. And divide by 3. So x equals 80/3. Check. Is 2 plus the square root of 3 times 80/3 subtract 16 equal to 10? Well, 3 times 80/3, the 3's divide out, that's just 80. 80 subtract 16 is 64. So 2 plus the square root of 64. Square root of 64 is 8. 2 plus 8 is 10. 10 does equal 10. That checks. So 80/3 is a solution. And number 4, here we have a cube root. Let's isolate that radical, subtract 9 from both sides. We get 2, so we have the cube root of 2x plus 4 is equal to 2. Radical is isolated, so now we raise both sides to the 3rd power. 2x plus 4 equals 8. Subtract 4, 2x equals 4. Divide by 2, x equals 2. Check. Back into the original. The cube root of 2 times 2 plus 4, that's still under the square root, or sorry, cube root, plus 9, does that equal 11? 2 times 2 is 4, plus 4 is 8. The cube root of 8 is 2. 2 plus 9 is 11. 11 equals 11. All right. You're more than welcome to try the others, but I know this has been one of the longer videos. But we'll stop here. And this concludes our, actually, Chapter 3 notes.